Very nice to be here. I'm Duncan. I am the CTO of SuperDuperDB, which is an open source project and also a startup founded last year. Yes, so I'll just present a few slides, telling you a bit about the vision and the project, and then I'll demo some of the functionality, and then we'll go into some questions. So yeah, this is all about how to make AI happen in practice. So this is a quote from ZDNet, which seemed to like our library, so we like to brag about that. Suffice to say that this is sort of a problem. So making AI happen in practice is often about connecting AI with your data. So these two ecosystems have tended to live more separately. So AI don't think seriously about how to integrate data, and data people generally don't go so deep into AI. And now you also have out of left field sort of this vector search piece coming into the equation in the last 2 years, and that's sort of made it necessary to think about how these two things get connected. But actually, it was always there. So if you actually have done AI in practice and productionized it, at some point you're going to have to process sort of data which is in a production system and keep it up to date and so forth. And it's really a nightmare. And so this nightmare is sort of caricatured by this image here, where essentially you're going to have different bits of infrastructure, different tools, programming languages, and even different teams and skill sets trying to achieve this sort of integration of AI with data and bringing in this new world of LLMs and vector search. It's becoming very difficult. So what we're hoping to happen is to provide essentially a sort of virtual layer where AI engineers, developers, data scientists, and infrastructure people can sort of collaborate in a meaningful way. And that's sort of, in some sense, we call it bringing AI to the database. What it really is creating the primitives and the layer, the software layer, to actually allow that to happen. And we believe by doing that, you can essentially avoid having to set up your own MLOps and ETL pipelines. So, of course, under the hood, there are pipelines in what we're doing, and there are transformations, but this is not something you have to set up. And we'll go into it at the end. If you have a SuperDuperDB deployment running, then you can remain completely on the algorithmic and code level, and essentially only with a few configurations interact with the actual underlying nuts and bolts of those traditional worlds. And yeah, so we call that bringing AI to the database. In technical speak, it's creating this virtual layer, AI data layer. Yeah, so you don't have to build these pipelines to migrate and move data between different tools. You don't have to write Apache Airflow jobs. You don't have to featureize your data. And what's more is you have a full database deployment as part of your stack, as part of your system. And that's very advantageous if we're talking about doing things like retrieval augmented generation, vector search, and even if you're maintaining a bunch of different classification models, creating variants which refer to sort of labels in your database, different tags or filters, that can also be advantageous. So there are many reasons why you would want to do it this way. Okay, so this is our vision, is to become a sort of centerpiece in the modern data-centric AI stack. And it looks something like this. Essentially, we're connecting the data ecosystem with the AI ecosystem on the right. So as I said, these tend to be very disjoint, and the sort of thing that we have in common is that there are Python libraries to do both of these. So SuperDuperDB leverages that fact and is trying to create nice primitives in Python which are familiar to data people and also familiar to AI people. So I'll show you what that looks like in code in a second. And the idea is that this really is sort of completely flexible, that going forward, we're going to try and make it flexible enough to integrate any kind of database client and any AI framework model API, and even bring tooling from the general Python ecosystem into the equation, as well as vector search engines. Exactly. So deployment, development, search, navigation, analytics, sort of the types of things. So deployment is like going live, getting endpoints, and maybe the endpoints cross-reference your data. Development is, fine-tuning, training your models, experimenting on your data. And then this kind of new kid on the block of AI deployment, which is using AI to navigate your data and potentially using the models that you've deployed or developed in the same framework. Yeah, and we're Python first, that's clear. And you can see us on GitHub. So I'll add the links at the end. Suffice to say, this is kind of sort of what the system looks like on a very high level. So we have your data deployment here. So database, data warehouse. We support a range of deployments. And that's a given. And you install SuperDuperDB onto your data deployment. And SuperDuperDB allows you with our Python library to install models, APIs, do inference and training, and to do that very closely in conjunction with your data deployment. So you can save features, outputs, and vectors back into your data store, and then you can reference these in your application. So then you can, once you've set this up, get a REST endpoint, or you can interact from Python with this system, essentially doing things such as vector search or model predictions in a way which leverages the outputs and vectors and features which you've created in this sort of setup development process. So instead of sort of saying, here's development, there's production over there, we provide you one platform that should make it possible to do all of those things, and then it's sort of up to you exactly how you use it. Exactly, and interacting with this, obviously developing in Jupyter, saving the models into the system here, and then automatically getting endpoints. That's a very nice transition from development to production, which requires no additional coding. So if you can code it in SuperDuperDB in a notebook, you can also serve it behind a scalable endpoint and get jobs running on a scalable compute to prepare outputs at no extra cost. So it looks like this in more detail. You have your data backend. Excuse me. So, where are we? Okay, so you have your data backend here, and that would be essentially a database or a data lake. And we started with MongoDB. We have integrations now with tens of databases, and the system that we offer, the data layer, it looks a bit in our client like a database, but it is not a database. It is a data layer, so it virtualizes this layer for models and data to interact. There's several other components. So there's a metadata store, which saves information about the models, artifact store, which is for sort of storing large bits of data. And then there's an abstraction which implements computations, and that compute can be fully scalable and productionizable. And then there's, of course, a vector search component, which pulls data out of the data store and makes vector search possible. And that's even possible in a database which doesn't necessarily have its own vector search implementation. Yes, exactly. And we've actually, so you can do all of that on open source and set that up yourself, but we've now built an enterprise version of this, which is essentially a Kubernetes realization of what you saw on the previous screen, and your enterprise can deploy that, or you as a developer can deploy that yourself and manage yourself on-prem. So that's a typical requirement for data-intensive applications. You want to keep governance and control. So we offer it on-prem. And on top of that, we have some pre-built AI applications and a low-code sort of interface and admin interface to interact with that system. And this system you would deploy in your infrastructure, which is running a Kubernetes instance. Yes, but there's nothing stopping you, because the software is end-to-end open source, permissibly licensed, to setting this up yourself and maintaining this as you would like. And I'll demonstrate what that looks like. So I could show these code snippets here, but I think now would be a good time to look actually at the repository and look at what the code looks like there. So in the interim, let's see if there's any questions. Okay. So I don't see any questions yet, so I'll continue on to the next part of the talk, which is to look at our repository and the documentation. So we're on GitHub, we're Apache 2 licensed, and you can see everything here. Obviously, it's a Python package, so install via pip. Lots of information here about how to do that, how to connect, and also our partners and integrations. More comprehensive information is to be found on our documentation. And here, you'll see high-level descriptions of the philosophy and what we're trying to do. But I think the most useful part of this is to look at a few example use cases. And to be clear, these are examples. So you can really, we believe, do anything with the system, especially beneficially for data-intensive applications. But in principle, you can do many of the things you would do usually with your AI and data. And let's look at, for instance, multimodal vector search. So what does multimodal vector search mean? That means searching through data of various types, for instance, text or images or videos or audio or some weird format that only your company knows about, some weird YAML format, who knows? And I want to do that kind of, I want to have options. So I don't want to go to some proprietary provider who says you've got to now pay for this and you have to use our database which you don't have access to, and you have to use these models which we've partnered with, this kind of thing. We want to get away from that. We want to make it really possible to control the whole process end to end, but still have like a nice, elegant way of interacting with systems. So you'll see that here. So the first thing we're going to do is to connect to SuperDuperDB, and there's two ways of doing that. One is via config file. So you can look, these config files are basically identical, apart from just a single configuration difference here. And the same is true if you're connecting in this way. So basically, it's just a single connecting command, which allows you to connect directly to your data backend. And there's two ways, because this whole setup can be run in two ways. So the first way is to work in a notebook locally, have all of your compute running in the foreground, and that's nice for debugging and experimentation. But if you want to actually use scalable compute and a productionizable system, you're going to want to configure an array cluster. and I'll talk a bit about what that is in a second, and also change data capture and vector search. So the idea is here that you can essentially you can toggle between something like this, which is a fully scalable system with schedulers, workers, vector search running its own process, change data capture, which is capturing data coming in from sources which aren't SuperDuperDB related. You can toggle between that and more standard AI setup for these types of things, as you might be familiar with in LangChain or Llama Index, where you don't necessarily have this scheduler doing work for you, so things are running in the foreground. And that way of working is nice if you're just playing around on your client and want to get things going. But for organizations and for bigger projects, that's not going to be production ready. So we allow these two ways of using the system. So you can start the cluster, so not an enterprise deployment, but something that you can just get going with on your system like this. And then we can showcasing in this notebook, in this use case, that we can handle any type of data. So here's some sample data which is linked to directly in these use cases. And once you've got that sample data, what you can do is you can define a new data type which your database may not natively support, like PDFs or images, and you can actually do that with full control. So you can even write a pair of functions which connects your database with the sort of raw data that you're inserting, that allows you to retrieve that data in the form that you're hoping to use in your models. Right, so for here, for instance, I've created the WAV data type, and what that's going to do is it's going to save blobs of data in my data deployment, and when I recall that data with the SuperDuperDB connection, I'm going to literally have nice audio objects in Python, which are going to be able to talk directly to my models. Okay, so now we go on to the next bit. So once you've got your data types, you can add those to your tables and collections. So what we're going to do is we're going to basically define a schema which tells the system what kind of columns do I have. So I could have, for instance, here, I could have a string column, I could have an image column, and something else, right? Once we've got that, then the next part of the process is exactly like inserting normal data, except that I can actually work with these complex objects, such as images and audio and so forth. And so once I've set up my tables and collections, we're just using a standard insert command, as you might do with any database. Right. Now, queries in SuperDuperDB, they use the underlying sort of language of your database. So for MongoDB, we have the PyMongo client, and for SQL, we have a formalism based on IBIS, which is a package which helps you build Pythonic queries for SQL databases, but where the queries are highly performant. And that allows you to sort of easily port your code from one database to another. And then we can do anything with the data which is in there. So for instance, here I want to chunk the data, and chunking depends on what kind of data I have. And to do that, I can just write my own Python function. So I don't need, Llama Index magic chunker or LangChain magic chunker or this proprietary chunker. I can just do a little bit of wrangling in an inline function and just link it to the system with a decorator. Right? And this works for any type of data, including video. So for instance, here we're using OpenCV to extract frames out of a video. Right? And then universally, once I have that chunker, I can just wrap it with a special keyword listener, which basically says apply this model to this query on this key. And also don't just apply it, but also apply it to any new data coming in. Right. So once I've got that, the apply command activates this model on the system. And now I'm ready to, once I have my chunk data, to apply a variety of models depending on the data I have. So for instance, text, I can apply a sentence transformer or an OpenAI embedding. Images, I can define my own torch vision model. Then you could do, for instance, clip if you want to do multimodal embeddings. And so here's an example of an audio embedding, which we've used librosa for. So it's very flexible, and you can bring sort of diverse components from the ecosystem. And then now we've got, once we've applied that, we've actually got the ability to turn our data into vectors. So now what do I want to do now? So now we want to search for those vectors. So what I'm going to do is I'm going to make sure that those vectors are always up to date. So I'm going to wrap that same model with this listener keyword again. And then I'm going to wrap the listener with a vector index. And what that says is, for this set of outputs, which are constantly being updated by the system, I want to make them searchable. So that would be this command. So simple declarative syntax. And I'll also show you how you can do this in one command at the end. So the whole notebook in one command. And then once that's in there, essentially under the hood, the system is going to be computing these vectors. And when it's ready, you can actually then construct queries which utilize your database's filtering functionality, but also the vector search functionality. So that looks a bit like this. So what you would do is you would take a standard query. So this is a find query from MongoDB, and then you would augment it with this like keyword. And the item here can be the image, the video, the audio, or the text. And yes, exactly. You're going to be able to search through your data and then also post or pre-filter the results using the query API of your database of choice. Right? And when that's done, you will, obviously, this is just us showing the results. So that's to give you a flavor of how flexible the system is and what's possible. And let's not forget, this is not just about vector search or LLMs. This is really about anything. So here's an example of much more traditional ML, just transfer learning. So featureizing with a computer vision network or an embedding textual model, and then doing some classification with scikit-learn or a similar package is also possible. So please explore those use cases and look at the diverse possibilities that sort of spring. And we're just scratching the surface on this, and we're hoping that developers will build a sort of new type of productionizable application essentially using this. And I'll talk a bit about this in the last few minutes, how that relates to our longer-term vision and so forth. So let's just look at enterprise now. So I'm going to log in here. So this is a managed on-prem deployment hosted on our data center. And when I log in, I see a bunch of configurations and settings, right? And these speak to that configuration system in the open source project, which you saw earlier. So basically, I could develop all this in open source, and then I could take my settings and my configurations and, in principle, deploy them here. Right, so that's the configuration, and this is powered by a sort of a Kubernetes set of Kubernetes operators. So we're able to connect directly to some Kubernetes deployment, and the system sort of auto detects what's going on there, and we can look at the hardware and so forth here. So those are the sort of underlying nodes that are present. And SuperDuperDB, as we saw on this image here, it has a variety of services which are necessary to be set up so that this thing works. So what you can do with this system is essentially configure where you want the different services to run on this cluster. So we can look at that here. The compute class basically allows you to assign these services to one of the workers. So the workers are given compute classes. Okay, in this deployment, they're all the same, but I could have like GPU worker or higher memory worker, and then say these ones here need GPU workers, and this one needs a high memory worker, and then just click this essentially together and use your own in-house Kubernetes in a flexible way with SuperDuperDB. So that's what's going on there. And how can we combine this with our open source development workflows? So imagine I'm working on my local client, and I'm going to essentially try something out in just a mock database. So I don't even need a real database to test this system. Just an in-memory mock. And once that's ready, I'm ready to actually, so once that's working on my local client, I can just simply import it into the Kubernetes enterprise self-hosted environment. So I'll show you a bit what I mean. So here I've just basically prepared the documentation of SuperDuperDB as a text file, and I'm just going to insert that into the database. So you can see that was successful, and so that's then there in the data backend, and that was achieved by a standard MongoDB query. And now what I'm going to do, by the way, this thing is a RAG app. So I'm in this notebook, I'm setting up a RAG app, and then I'm going to import that RAG app to the enterprise deployment. So RAG, the first step of RAG is to create vector search. So that's what I'm going to do here. I'm going to create a vector data type, a model, which is going to create vectors, a listener, which is going to activate that model, and the vector search, which is going to say those outputs, those vectors should be searchable. So this is sort of recursive, so I only need to apply this one, and the whole thing should basically work. Yeah, so you can see what's happening now is that the system, which is running on my client right now, is preparing the vectors for search. And you can see this is running the foreground, so I connected in this way, so I'm not running a scalable sort of cluster-like deployment. I'm just testing things. So now it's done. Now what I'm going to do is I'm going to create a LLM model which uses the vector search functionality. So it's a little bit more involved. Basically, what I'm going to do is I'm going to create a sequential model which chains together the prompt with the LLM. And the prompt is just something I've imported from the package, but remember you can define these components completely flexibly yourself. And by the way, when I say define, I don't mean go to our repo and make a pull request and wait for us to. No, I mean you can really locally develop and serve that in the system. Right. So just testing that this makes sense. Okay, so we've asked it a question about vector indexes in SuperDuperDB, and it seems to have gotten a good answer here. So I'm happy with that. So basically, I've got two components. I've got the RAG model and the vector search model. I'm going to package those now, right? So that is called a stack, and I'm now packaging my app in some sense. This is a RAG app, two components packaged, and I'm going to now export it. And if I open the file here, you'll see that there's a JSON artifact created, which basically looks a lot like the code that we just wrote. So I'm writing in Python, I'm testing in Python, but then we have a formalism under the hood, which is logging all of this, and in a kind of human readable way, saving that. So you can kind of see what's happening, but you can also, this is now portable, right? And those artifacts that you saw in the directory, let me just show that again. So if I there are two artifacts here, right? So these are referenced in some of the components. And what is an artifact? An artifact is something which doesn't nicely export to JSON. So why don't we just put the whole thing, bundle the whole thing in a big blob and sort of save that? Well, because then you won't be able to see what you're doing, and you won't be able to decompose this thing. So what we're trying to do is serve as much with JSON as possible, and then for the difficult things like weights and data binaries, we're gonna export that as bytes. So if you know, in Python, there's sort of this trend to create data classes in Python data classes and Pydantic. So ideally, we would like to use something like that, but it's not really possible right now with the state of the Python ecosystem. So if you look into our code base, you'll see something that looks a bit like Pydantic, but it's more flexible, and we think it's what data scientists and machine learners need to do this kind of thing. So it's not pedantic like Pydantic, it's a bit more flexible, but it gives you that level of kind of nice transparency between configuration code and serialization. So we're pretty excited about that. But that's not the whole point. The whole point is to now get this onto your data. So now I'm in here, you'll see there's no components loaded, nothing there. So I'm going to add this stack that we just created. So I'm going to upload that JSON. You see it's now there. And I'm also going to upload the artifacts which we created. Right, so those are essentially Python classes there, which have been uploaded. And so this thing here now defines the stack. And if I then click add, something's happening in the background. And within a few moments, you should see something like the following. All right, so it's successfully added. And you see we've got the components that you saw in the notebook are now here in the system, and they're sort of separate components, and you can look at their configurations individually. And also you can look at like what's going on. Like, so this was an embedding model, and you can see it's got array job assigned to it. So that means this cluster in the background has kicked into action, and it's now processing the data. And array is very nice. It gives you this nice dashboard which we've embedded here, and you can look at what's going on with the computation. It's in progress, and with a short period of time, we will be able to use that. So now I'll show you a little bit the query interface. So here you can write standard database queries. So there's one. So you can see this is in progress. We've got one record that actually has the documentation. At the same time, you can see the outputs created by the job. So the job is going through and vectorizing these things. Yes. Let's just have a look back here, and you can also see the array dashboard here. All the different jobs and different features of array. We want to leverage all of that in what we're doing. Another thing, we have a Jupyter Notebook hub where you can interact directly with your system. So all of the configurations and connections are configured in there. So that's an alternative way. So we've got different ways to interact with the system. One is from outside, uploading this thing. One is to build the components in the system, and another is to actually you can actually sort of click this together in some sense. So some of these things are predictable enough that you can sort of click this together, and on the output you'll get something similar to what we've uploaded. So we've got this nice symmetry between what's going on here, the open source, and the Python part. So let's just look back here and see how that's going. So that's now finished. So that means that the model's in the system. So now let's try see what happens if we do this. Right. Exactly. So here we've got a slightly different answer to before, because ChatGPT doesn't always give the same answer. So I've used ChatGPT here, but you can also use self-hosted LLMs, have much more control. That's a question for you to decide. We just want to enable you to use these. And what's kind of cool here is that this is a query, right? But it's not really a query because it's a model. And so, queries in SuperDuperDB are like a mix of models and data queries. So we have a new paradigm, like querying your data with a model in a query API, which looks a lot like a AI open source package, but also looks like the open source database clients that you're also used to. The camera's not on. Sorry for the interruption. Yeah. So, okay. So that's building an app end to end. And if you want to read more about this example, this is very similar to the basic hello world example in the documentation. So that's a good place to start. And if you want to go deeper on retrieval augmented generation or multimodal vector search, you can see that in our use cases here. And then go much deeper with fine-tuning your own LLM. So I don't mean prompt design. I mean really fine-tuning the weights of your LLM and more. So we've got a few minutes left for questions. Maybe if any of you want to ask things, we can go through that quickly. So I will share these links that we have in here. So the multimodal vector search, our GitHub repository, and let's see, what else do we have? Yeah, so that should give you almost all of the information that I shared with you today. We've got an upcoming launch. Version 0.2 of our package will be released probably towards the end of the month, as well as the first version of our managed system. So please stay tuned for that and join us in Slack, which you can see here. If you look at our website, we have Slack invite. There we go. Sorry. And here's our website. Yeah, we'd love to hear your feedback. And I hope you enjoy the rest of the show. Great, then. Thanks for listening.